Hello. Sorry to shuffle my papers. I'm going to do three different limit examples. First, I'm going to do this one, write the first four terms and find the limit. Well, my first four terms, when n is equal to 0, I get 1/3. When n is equal to 1, I get 6/5. When n is equal to 2, I get 11 over 2 times 2 is 7. So you can see the pattern. I'm increasing the top by 5 and the bottom by 3. Okay, so you can probably guess what the limit's going to be. It's going to be 5/2. These powers aren't really going to matter, so I'm going to get 5/2. But let's see what happens. Okay, that's going to be equal to infinity over infinity. That means I can use L'Hopital. I take the derivatives. I get 5/2. Limit n goes to infinity. 5/2 is just 5/2. That's my answer. Okay. Here's another example. Here you have to find the limit, and we have to find the an in order to do that. So I'm going to start my count here. N is equal to 1, n is equal to 2, n is equal to 3. And I'm going to look at the pattern. I'm increasing each of those by 1, and then I'm increasing each of these by 1. So I'm going to do this one first. If n is equal to 1, I'm increasing by 1, so I'm going to get an n, because my increase is 1. Like in class, when the increase was 4, we used 4n. And then I'm noticing if n is equal to 1, that's plus 3. If n is equal to 2, plus 3, plus 3. So I get n plus 3. Now this one's going to be a little bit more. Again, my increase 6, 7, 8 is 1 each time. So I'm going to get an n. But here I'm adding 5, I'm adding 5, I'm adding 5. So that's going to be my an. So I need to take this limit and you can see that this limit is going to be 1 over an n squared term. So I FOIL this out, I get n squared, 3n, 5n, 8n, plus 15. Well, that's going to be clearly 1 over infinity. So this limit's going to be 0. Okay, again, I'm not using the limit definition here. We don't need to use that definition. I'm just doing it the old-fashioned way. Okay, so that's